So now we're going to start looking at some numbers and creating a path analysis example using our situation with Maverick and Charlie, and they're trying to find out what predicts a good dogfighter. Well, so first, like we talked about earlier, we got to have very careful theory and empirical literature review. We don't necessarily have that here, but you would definitely want to do it. And then you're going to draw the model. Well, here's the variables. We have this need for speed variable that Maverick thinks is a big deal. This family variable that Charlie thinks might happen. Then the testing variable. Both of these are kind of Charlie's. And then we have this dependent variable, which is their dogfighting scores. And one of the things you may notice, the double line squares indicate that these variables have been transformed to z-scores, so that it makes the results a little bit more interpretable. So then you start to create a model based on your theory. So so let's just say this is the model that we predicted, in which all three of these variables are predicting dogfighting skills. And then we're going to allow for a relationship between these two and these two, but not between these two. Don't have any reason for that. This is just an example. And so each one of these is an observed variable, each one of the boxes. And then when you have a direct line, that's a predictive relationship, like a regression weight, when you've got z-transformed variables. And so what that shows, that's the same as a regression beta weight. These curved lines are called covariances, and this allows for the correlation between the observed variables. It's normally done if you theorize that there's a relationship there, you should allow them to covary. So, but when you think about a theory, it could be lots of different things. Maybe this is kind of like a multiple regression model, whereas maybe this is what they would call a fully identified model, where just about everything is connected with everything else. Okay, and you would think that might help, but here we have that need directly predicts dogfighting, but it also predicts test scores, and then could also kind of have an indirect effect through test scores. Family might directly affect dogfighting, but it also might have a mediation effect or an indirect effect going through test scores. And whereas we would have a theory here where we just allowed these to be to covary, but we're not predicting any type of causal or predictive relationship across these two variables. Another possible model could not allow these to be related at all, or even leave out this relationship between test and dogfighting, and just go with an indirect effect relationship. So there are lots of different ways you could draw a model. That's why you have to have a good theory. And consider, even once you choose the best model for what you're talking about, there could still be another one. And so don't be too confident in whatever kind of model you're looking at and say this is the only one. And so, and the other thing you'll see, a lot of times these numbers here that appear above the squares are the variance of that observed variable. Hey, but if you screw this up, you'll be flying plane full of dog stuff out of Hong Kong, so better get it right. Have a good theory, start testing your models, and we'll talk about that in the next video.